A quadrilateral has all integer side lengths, a perimeter of 26, and one side of length 4. What is the greatest possible length of one side of this quadrilateral? So for this problem, we're going to need essentially a variant of the triangle inequality. Except that it's going to be extended to quadrilaterals. So we'll call it a quadrilateral inequality. So let's remember what the triangle inequality says. The triangle inequality states that any two sides of a triangle, their lengths have to add up to a number that is strictly greater than the third side. So if A, B, and C are the sides of a triangle, then the sum of any two of the side lengths has to be strictly greater than the length of the third side. So another way of phrasing the triangle inequality is that if the sides are ordered in terms of length, so instead of stating 3 inequalities, then it's just enough to say that the sum of the shorter two sides is strictly greater than the third side, because the remaining two inequalities are redundant. So we're going to need a version of this inequality for quadrilaterals. Now let's think about why the triangle inequality is true. This is mainly because the shortest distance between 2 points in a plane is a straight line. So therefore, any other sequence of segments will have length greater than c. So now we can extend this to a quadrilateral version of the triangle inequality. And we'll state that if A, B, C, and D are the side lengths of a quadrilateral, and again, we're assuming that they're sorted in increasing length, then the sum of the shorter of three sides has to be strictly greater than the length of the longest side. So we're going to apply this inequality to find the greatest possible length of one side of this quadrilateral. So note that the perimeter is 26. So therefore, A plus B plus C plus D is 26. And we're trying to find the greatest possible length of one side of this quadrilateral. So therefore, we can find the greatest possible length of the longest side, which we're going to assume is D without loss of generality. So because we know that A plus B plus C has to be greater than D, it also follows that A plus B plus C plus D has to be greater than 2D. And we know that the perimeter is 26, so dividing both sides by 2 of this inequality, we therefore get that 13 is greater than D. And because all the side lengths are integers, therefore D has to be at most 12. So the answer is D. And just to check, we can confirm that there is a quadrilateral that has a side length of 12 and a side length of 4. You can simply choose the remaining two side lengths pretty freely. So 8 and 12 is 20, so 6. So we can construct a quadrilateral that has two sides of length 4, one side of length 6, and one side of length 12. Therefore, 12 is indeed possible.